a complete outer electronic configuration with 8 electrons in their outermost shell.
Okay, so atom can only gain, according to you, Aisha.
How?
So according to you, the atom can only gain to complete its octet, right?
Okay.
Yeah.
No, Aisha. So I just said that octet rule is when the atoms tends to gain either or lose or share electrons to achieve a full outer electronic configuration of 8 electrons in it. Okay, so it can either gain or sometimes it lose or sometimes it share electrons to achieve the uh, outer electronic configuration of 8 electrons. Okay, so that's the octet rule. सिर्फ वो gain नहीं करेगा, वो lose भी कर सकता है और share भी कर सकता है electrons. Okay, to achieve the 8 electrons in its outermost orbit. That's the octet rule. Clear? Now see, what are the limitations of octet rule? So octet rule has many limitations. It doesn't explain, write down, write down along with me. First point, the octet rule is not applicable for hydrogen atom. Why it is not applicable? Because a hydrogen atom can accommodate only 2 electrons. Can accommodate only 2 electrons. That's why the octet rule is not applicable for hydrogen, for hydrogen atom, as it can accommodate only 2 electrons. Two electrons. Second point. The second limitation is that this octet rule doesn't explain the stability of electron deficient species. The electron deficient species, just like certain molecules, like the molecule which contains your lithium, right, beryllium, boron, they have fewer than 8 electrons around the central atom, right? So there are certain molecules, especially those involved this lithium, beryllium, boron, etc. They have fewer than 8 electrons around the central atom. For example, if I write the molecule of lithium, LiCl, Be, BeCl2, BCl3, right? So here the central atom is lithium, right? Lithium, beryllium, and boron. So they have one, lithium has one, this has two, one, two, and three valence electrons respectively, right? So lithium has, this is a central central atom in this LiCl. This is BeCl2. This is the beryllium is a central metal, right? So it has a valence electron 2. And in this BCl3, it has valence electron 3, right? So these have very few valence electrons. So due to that, fewer electron deficient species you can say. So for example, if I say मैं example से समझाती हूँ, like just a second. First write down the note. First write down, this octet rule does not explain the stability of electron deficient species. Electron deficient species which has a valence electron of very few, which has very few valence electrons, means less than 8. Okay, suppose, write down the example, like your LiCl. We are talking about the molecule, we are talking about the species. So these are basically electron deficient species. So this octet rule that doesn't explain the stability of electron deficient species, like BeH2. Another example, BeF2, BF3, BCl3. Some examples are BH3. These are some examples of electron deficient species. Okay. Now see, if suppose if we take the example BeH2. Try to draw the skeleton of this BeH2. So Be and hydrogen, right? Now we know that beryllium has how many valence electron? Write down the electronic configuration and tell me the how many valence electron in beryllium. Two.
Two.
So yeah, it's two. And hydrogen has one electron, right? Now see, if you see that suppose यहाँ पे sharing हो रहा है, the bond contains, if you draw the proper skeleton, hydrogen, so this is your two electrons. Okay. So when the hydrogen share one electron to this beryllium and this hydrogen share one electron to this. Now see, check how many electrons are for central atom. Central atom is beryllium. Now check it how many electrons are there? 1, 2, 3, 4. Only 4 electrons are there. Means this is electron deficient species. Its octet is incomplete. Okay, ये और electrons कहाँ से लाएगा? Hydrogen is again electron deficient, right? So the bond formed by BeH2 is electron deficient species, and the octet rule doesn't explain the stability of electron deficient species. Is it clear?
Yeah, mom.
Yes, ma'am.
And similarly, if I draw the structure BF3, okay, BF3, right? Now we know that how many valence electrons are there in boron? So its atomic number is 5, so 2 and 3. So 3 electrons, 1, 2, and 3. And how many electrons, valence electrons are for fluorine? So 2 and 7, right? So 7 valence electrons. So just show it. 1, 2, 3, 4, 5, 6, and the 7. Okay, similarly 1, 2, 3, 4, 5, 6, and the 7. 1, 2, 3, 4, 5, 6, and 7. Okay, now check the valence or the total electrons in the central atom. So 1, 2, 3, 4, 5, 6. 6 electrons. After sharing, okay, after sharing and after the bond formation, the boron has only 6 electrons. Okay, so it doesn't, you can say, ये आपको octet rule follow नहीं करता है. And the octet rule doesn't explain this type of stability for the electron deficient species. Is it clear? And you can similarly draw any structure like LiCl, BF2, BF3, BH3. So you will find that in this the octet rule doesn't, you can say it doesn't explain the octet rule, the stability of this electron deficient species. Clear? So that's the major limitation of the octet rule. Third one, write down. Also, octet rule does not explain the stability of electron rich compounds. Okay, electron rich compounds के लिए भी ये explain नहीं करते octet rule. Okay, for example means the electron rich compounds means the electron rich compounds means the having more than 8 electrons, in the you can say in the valence shell, Vs is the valence shell. Okay, for example, let's see. Suppose we have PF5. Now, who will tell me which one is the central metal, central atom? In PF5, which is the central atom? Yes. Yes, phosphorus. Yeah. So the more electropositive element, we take it as a central atom. Okay, electronegative को हम central atom नहीं लेते हैं. I think we have discussed in the previous class. Right, which atom should be taken as a central atom? Yeah. So hydrogen and fluorine will never be a central atom. The less electronegative element will be a central atom always. Okay, so just remember this point. Okay, so in PF5, just try to draw the structure of PF5. So the structure is just like P, F, 1, 2, 3, 4, and 5. Okay, and I just told you one bond is for the two electrons. Okay, one bond consists of two electrons. So now just calculate the total electrons of phosphorus of the central atom. How many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. 10 electrons, right? So in phosphorus, how many electrons are there? In its valence shell, so it's 10 electron, which is more than 8 electron, right? So that's why the octet rule doesn't explain the stability of electron-rich compound. This is electron-rich compound. The electron is more than 8 in the valence shell, right? So that's why that's the example. Second example, you can write SF6. SF6. Okay, now try to draw the structure first. 2, 3, 4, 5, and 6. Okay, now tell me what is the how many electrons are for sulfur for the central atom?
Well,
Yes, very good. It's 12 electrons. Okay, so 12 electron is more than 8 electrons, right? So that's why that's a major limitation of octet rule. It doesn't explain the stability of electron-rich compound and electron-deficient species. Clear?
yeah, ma'am.
Any doubt here? Okay,
No, ma'am.
fourth one. Write down the fourth limitation. It does not explain the stability of odd electron species. Odd electron species. Now, what does it mean? Odd electron species or molecules. So, see, molecules with an odd number of valence electrons, just like your example, you can take nitric acid, right? And nitrogen dioxide, NO2, right? So they also violate octet rule, okay? Because it doesn't explain, the octet rule doesn't explain the stability of odd electron species. And in these cases, in nitric oxide and nitrogen dioxide, they suppose when you draw the structure, of this NO2 and NO, okay, so see, so when you draw the structure of NO2, right? So this nitrogen, okay, this oxygen, okay, so 1, 2, 3, 4, 5, 6, and here 1, 2, 3, 4, then this one, and here one lone pair, and one electron on the nitrogen. Okay, so you can see over here only one electron is there for nitrogen, which is odd, right? Now you can check how many electrons are for 1, 2, 3, 4, 5, 6, and this one is 7. Only 7 electron is there, right? One electrons की कमी है यहाँ पे. There is a lack of one electron to complete its octet. Okay, so and after sharing, this is after sharing, after the bond formation. This is the electron which is for one electron. So you can see only one electron is non-bonded. One electron is non-bonded for nitrogen. So that's why the octet rule doesn't explain the stability of odd electron species. Okay, this is one. So this is odd electron, right? So when the odd electron is there, then it can also violate the octet rule. Okay, in the just like your nitric acid के case में, nitrous oxide के case में. So both are the examples when it doesn't violate, or you can say it can violate the octet rule. Okay, and if अगर आपको यहाँ पे समझ नहीं आ रहा कि how this structure came, so I just told you in the previous class, step by step, how to draw the structure, right? What are the steps? What are the steps to draw the structure? Right. So first आपको क्या करना है? First, try to, yeah, yeah. This is the determine the total valence electron, okay, in the species. Now draw the skeleton. And the third one is add remaining electrons to complete the octet. Okay, after these three steps, you will got this structure of NO2. Okay, after this structure, and one electron is unbonded. One electron is unbonded, and that is odd electron for the nitrogen. I'm just talking about the nitrogen. And if I ask you what is the formal charge on nitrogen, so how you will explain it? Calculate the formal charge on nitrogen. Did you guys revise the previous class notes? Yes or no?
Yes, ma'am. Can you repeat the question?
What is the formal charge on this nitrogen in NO2? Will you calculate the formal charge? Total valence electron.
Ma'am, 0.
Okay, let's check it. Total valence electron minus lone pair electron minus bonds. Okay. Now tell me how many total valence electron in nitrogen? Yes.
5.
Yes. Very good. Lone pair electron.
1.
How many bonds are there?
3.
Yes. So 1 minus 4, so it will give you 1 plus 1 charge. Plus 1 charge on this nitrogen. Okay. So that's how you just calculate the formal charge. Total valence electron minus lone pair electrons minus bonds. You can write a bonds, or if you don't write the bonds, so half 1/2 multiplied by the number of bonding electrons. Okay, so two formulas I have discussed it over. So just remember that. That's very important. Okay, so these are very important. So the octet rule, limitations of the octet rule. Four limitations are there. So just remember that limitations with examples. Any doubt in this?
No, ma'am.
No,
Okay,
can you once again scroll to the third point? Ma'am, the third point.
third point. Okay.
Okay, ma'am.
Okay. Okay, right on the next topic, the theories. Or you can write bonding theories. Okay. So this topic is very, very important. Okay, bonding theories. First theory we will discuss. So basically two bonding theories are in your syllabus. First one is your valence bond theory. Valence bond theory. VBT. And the second theory is your molecular orbital theory. Right, anode. Okay, now write on the first one. This is your first valence bond theory, BBT. Okay. Now first try to understand what is BBT, valence bond theory. So again, it's a theory in chemistry which explains how covalent bonds are formed between the atoms. Okay, we will discuss how the bond formation between the two atoms. Okay, so basically write down. It explains valence bond theory explains how covalent bonds are formed are formed between the atoms. Okay, and it states that valence bond theory states that a covalent bond is formed when the atomic orbitals of two atoms overlap with each other. For example, if we have A, okay, it has a orbital, and in the orbital only one electron is there, right? One unpaired electron is there, and suppose there is a B atom and its orbital, and one electron per is and one electron is. Okay, so one unwanted electrons are there in the orbitals of A and B. A and B. Okay, now how the bond formation occurs basically when this orbital overlap with the orbital of the B. Suppose this is A orbital, this is B orbital. When they overlap with each other, so here the formation of covalent bond occurs. Okay, so basically the valence bond theory क्या कहता है? It explains that it states that covalent bond is formed when the atomic orbitals, these are the orbitals, these are atomic orbitals. Okay, so when the atomic orbitals of two atoms they overlap with each other, which allow the unpaired electrons to pair up. They are the unpaired. Okay, एक single atom की बात की जाए तो they are unpaired. One electron is unpaired. Similarly, B में भी क्या है? One electron is unpaired. So when they overlap, what happens? These unpaired electrons are paired up. यहाँ पे क्या होंगे? They paired up. Okay, which leads to a stable molecule, which leads to a formation of a stable molecule and a covalent bond. Is it clear? What is
Yes.
valence bond theory? And yeah,
Yes, ma'am.
now you can write down. It states that a covalent bond is formed when atomic orbitals of two atoms overlap, allowing their unpaired electrons to pair up, which leads to or leading to the formation of leading to a stable molecule. Okay, so basically valence bond theory focus on the atomic orbitals of valence electron. Okay, we will talk about the valence electron only, outermost electron की बात होगी, because outermost electron participate in the bond formation. Okay, so this valence bond theory, it focuses on atomic orbitals of valence electron and how they interact during the bond formation, right? Now let's see how they overlap. So write down. And you can write one. Here you can show by using this example. Suppose A is there, B is another atom. When the bond is formed, so A B orbital Suppose if I show the yeah, and always remember because we have discussed in the I think second unit, right? Second unit में हमने discuss किया था that if one electron is the spin of one electron is this upward spin, तो second का क्या होगा? When they are making bond with each other, when they form the bond, so it will be down spin. Okay, then only the formation of the bond will occur. For example, this is your A, इसका up spin है, and the valence electron of B, which has a down spin. So when the bond is formed, so the pairing will be like this. The pairing will be like this. Okay, so this is the overlapping of orbitals. Overlapping of orbitals. Right? And the bond आप कैसे show करोगे? AB. This type of bond is formed. Is it clear?
Yeah, ma.
Okay. Now see, and yeah, always remember the greater the extent of overlapping between the two atomic orbital, stronger is the bond. जितने ज्यादा एरिया पे ओवरलैपिंग होगी उतने ज्यादा स्ट्रॉन्ग होगा हमारा बॉन्ड. Okay, it's very important. So write down greater the extent of overlapping between two atomic orbital, stronger is the bond. Stronger is the bond. Yeah. And for every effective overlapping, there must be a proper orientation between the two atomic orbital. Proper orientation honi chahiye, then only the overlapping will be there. Overlapping occurs. Suppose if the orientation of okay, let's see first. Let's understand the types of overlapping. Then we will discuss that. Write down the heading: types of overlapping. Types of overlapping. Okay, so there are three types of overlapping. First one is positive overlapping. Positive overlapping. Second one is your negative overlapping. Negative overlapping, and the third one is your zero overlapping. Okay, now one by one we will discuss what is positive overlapping. Okay, so always remember, due to this positive overlapping, bond will form. Bond will form. Only positive overlapping में ही bond formation होगा. Okay, but in these two, the negative and zero overlapping, bond will not be formed. Bond will not form. Just remember that. Bond will form only in the case of positive overlapping. And now what is positive overlapping? Let's discuss it. Write down first positive overlap. Okay. So positive overlapping is that type of overlapping in which the atomic orbital has same sign. Suppose we have suppose s orbital, and we know that s orbital का shape क्या होता है? It's spherical, right? It's spherical, so it's a positive. So the second atom is again the positive one. Then the overlapping between these two leads to the formation of a bond. Okay, these leads to a formation of a bond, and this type of overlapping with the same sign of wave function. What is it? This is a wave function psi. This psi unit. Okay, we have discussed, I think, in the second unit. atomic structure, right? So this is a wave function. So overlapping of atomic orbital with the same sign of this psi, which leads to the formation of positive overlapping. Will leads to the formation of positive overlapping. Okay. Suppose यहाँ पे again we will take the s orbital. We know that s orbital shape is spherical. Suppose this is a negative sign. Okay, the wave function is minus. Now, when they overlap with each other, so again the bond will be formed. Okay, the extent of this is the area where the overlapping occurs, right? So यहाँ पे bond formation होगा, and this type of bond formation is known as positive overlap. Is it clear?
Yeah, ma'am.
Yes, ma'am.
Okay, and always remember, bond will be formed only in the case of positive overlapping. Now write down overlapping of atomic orbital. This is AO is atomic orbital with same sign of wave function. The psi is your wave function. This is psi, right? This which results in attractive forces, which results in attractive forces. Okay, which leads to the formation of a bond. Okay, you can write down the example also. Plus, again the same charge, so it will lead to the formation of bond. Overlapping. You can show the overlapping. Similarly, s orbital, with negative charge, again they will, because they have a same sign of psi, so again they will overlap with each other and they will form a bond. Okay, one more thing. See, if suppose this is a s orbital, okay, plus we have a p orbital. P orbital shape क्या होता है? It's a dumbbell shape, right? It's p orbital, and suppose this is a plus, this is a minus. Two lobes are there in p orbital, right? S orbital में तो only one lobes are there, or lobe is there, right? But in p orbital there are two lobes. Okay, so first lobe, this is, suppose this is positive and this is negative. And positive side से, for example, positive side से overlapping हो रही है, they interact with each other. Interaction is between this plus and this plus. Okay, the s and the p orbitals. So the bond will be formed. The overlapping will be like this. Overlapping as you. Okay, means from the same side where the sign is same. So this type of overlapping is known as positive overlapping. Similarly, if we take both the p orbitals, okay, suppose this is positive, negative, negative, and positive. Okay, so this is negative, negative means the same sign, so they will make with each other. Okay. And you have to show the overlapping. This was a positive, negative, so negative, and positive. Okay, so this was on the x-axis. When you take the py subshell, py orbitals, suppose these are py, py. So suppose this is a plus and this is minus, plus and minus. Okay, so in this case, how the overlapping occurs. So basically, ये side by side overlapping होगा, right? So see, this will be positive, positive, and this negative, negative. Okay, so the overlapping will show like this. Plus, plus, minus, minus. And here the overlapping occurs, and here the overlapping occurs. Okay, so all are the examples of positive overlapping, which leads to the formation of bond. Okay, only positive overlapping leads to the formation of bond. Just remember. Clear?
Yeah, ma'am.
Second, let's discuss the second one. Second is your negative overlapping. Negative overlapping. So the overlapping, what is negative overlapping? So the overlapping between the atomic orbital of different sign of wave function. Overlapping between atomic orbital of different sign of psi wave function. Okay, and this results in the repulsion of forces. Repulsion forces, you can write. Repulsive forces. This results in, which results in repulsive forces. For example, if we have a s orbital with plus sign, and if we have another s orbital with minus sign, so both sign are different, plus and minus. So what happens when they try to interact with each other? What happens? Overlapping will be there. Overlapping to hogi, right? Overlapping will occur. But in this case, this results in repulsive forces between the two orbitals. Due to that, the bond will not be formed. अगर form भी करता है, which is very unstable. Okay, the bond will be very unstable and bond का formation ही नहीं होता in this case. Okay, so just remember in negative overlapping, if there is a negative opposite sign between the two orbitals, okay, and they are trying to make the bond with each other, so overlapping will be there, but it results in the repulsive force, okay, and the bond will not be formed in that case. Similarly, if we take the, suppose, p orbital plus minus plus minus, again how you will show that? Plus minus, this is a plus and minus. The interaction results in the repulsion. Okay, इन दोनों के बीच में repulsion होगा and they will fell apart. Okay, so this is known as negative overlapping. Third one, zero overlapping. Zero overlapping. Now, what is zero overlapping? So overlapping between the atomic orbitals with the same and opposite sign of psi simultaneously. अब simultaneously आप क्या करोगे? You will see the same sign and opposite sign of psi simultaneously. For example, if and just a second, yeah. For example, if you take the s orbital, which is having positive sign, right, and the bond formation is between the s and p orbital. Suppose this is p orbitals, right? This is having plus and minus. So you can see in this, the overlapping of the orbital, of the atomic orbital, is basically the same sign, means with this plus and plus, this is the same sign, right? When the overlapping occurs, just a second, let me show the overlapping here. Suppose this is overlapping, plus and minus, right? So here the plus plus के बीच में क्या है? This will be the overlapping. Right here will be, you will see the attractive force between this plus plus, but at the same time there is a negative sign over here, opposite sign. So here you will see the repulsive force between these, right, between these. So these will be cancel each other. The attractive force and the repulsive force, they just cancel each other, and this is known as zero overlap. This type of overlapping is known as zero overlapping. So write down what is zero overlapping. So overlapping between atomic orbital with the same and opposite sign of site simultaneously is known as zero overlapping. Okay, so this is the example of zero overlapping. Similarly, if we take this was the S and P. S and P के बीच में जो bond formation overlapping हो रही है, that's the case. Okay, this one first one is a S orbital and this is a P orbital. For example, if we take both the orbital as P orbital, suppose this is your px orbital and this is your py orbital. Okay, alignment किस side होगी? Towards the y axis. Okay, so this is your plus, this is your minus, plus and minus. Okay, in the same case, you can see this minus and plus. Okay, these are the opposite sign. Okay, so here the repulsive force act. Here between these plus and minus, यहाँ पे क्या होगा? Repulsive force. And between this minus and minus, between these lobes, minus lobes and this minus, there will be attractive force. Okay, and both cancel each other and you will get the zero overlap. You will get zero overlapping. So this is the example of basically a zero overlapping. Okay, and this type of overlapping also results in repulsive forces. Repulsive forces. That's why the bond will not be formed. Repulsive forces. Okay, now write down the note. Write down the note. Only positive overlapping results in bond formation. Clear?
Yes, ma'am.
Ma'am, can you scroll up with the negative overlapping? I'll take a screenshot. Done, ma'am.
Okay, write down this.
Thank you, ma'am.
Now see. And yeah, one more thing. What is internuclear axis? Internuclear axis. Okay, so the word suggests that internuclear axis. So basically, it's an imaginary line which connects the nuclei of two bonded atoms. For example, if the bond formation takes place between these orbitals, this is your A orbital, suppose this is your B orbitals. Okay, इन दोनों के बीच में क्या हुआ? The bond formation take place, and this is the overlapping, positive type of overlapping. When I say the bond is formed, it means that the overlapping is positive overlapping, right? And so there is an imaginary line between the nucleus of the orbital of the two atoms orbital after the bond formation. And this imaginary line is known as internuclear axis. Nuclear axis. Clear? What is internuclear axis? It's an imaginary line which connects the nuclei of two bonded atoms. Okay.
Yeah, ma'am.
So this is suppose we have this is internuclear axis. and we have p orbitals, right? So this is the internuclear axis. Now see, in the case of, for example, if we suppose, let's see first the bond formation. Okay, so write down first. First is one lobe interaction. When only one lobe of orbital interact, then what will happen? One lobe interaction. Second is two lobe interaction. Two lobe interaction. And the third is when four lobe interact. Four lobe interact. Okay. So which type of bond will be formed when one lobe of orbital will interact with each other, when two lobe interaction will be there, and when the four lobe interaction will be there? So for write on the first, in this first case, when one lobe interaction is there, it means that lobes of atomic orbital are on the internuclear axis. When one lobe interaction, for example, see, only one lobe interact कर रहा है. See, in the case of s orbital, suppose this was s orbital, ये भी s orbital है. Okay, when the overlapping occurs, what you will see? So see, observe here, the lobes of atomic orbital are on the internuclear axis. ये lobes कहाँ पे हैं? Are on the internuclear axis. So when the lobes are on the internuclear axis, they just only one lobe interaction is there, and in this type of, when the one lobe interaction is there, so the bond which is formed is known as sigma bond. Sigma bond. Sigma bond को हम ऐसे show करते हैं. This is sigma. That's very important. Okay, when one lobe of atomic orbital interacts, and the lobes of atomic orbital are on the internuclear axis, then the bond formation जो takes place होगा, bond formation जो होगा, that is sigma bond. किस type का bond form करेगा? Sigma bond. Okay, is it clear? So see, in this two,
Yeah, ma'am.
first one, both are the cases where only one lobe is interacting. Okay, in this first also one lobe interact हो रहा है, second one also one lobe interaction हो रहा है. So in both the cases, sigma bond, ये जो बन रहा है, ये जो बीच में overlapping हो रही है, यहाँ पे जो bond formation हो रहा है, so that type, this bond is known as sigma bond. Similarly, this bond is known as sigma bond. Clear? So when one lobe is interacting, so the lobes of atomic orbital are on the internuclear axis. You can see the lobes कहाँ पे exist करे? Internuclear axis पे. And that type of bond formation is known as sigma bond. Similarly, two lobe interaction. So what is two lobe interaction? So again, two lobes will be interact. यहाँ पे क्या होगा? Simultaneously at the same time, two lobes are interacting, and the lobes are above and below the internuclear axis. Okay, suppose we have this was px, right? X k orientation, and now if I draw the py axis, py orbital, so this is py, and again this was the py, right? Two orbitals. Now the imaginary line is this, right? This is the imaginary line. This is the internuclear axis, right? And this, the overlapping is between this. यहाँ पे overlap हुआ है and यहाँ पे overlap. Okay. Now you can see over here. This is the example where the two lobes are interacting each other. One lobe, right? ऊपर देखो, this one lobe. Suppose this is a positive. This is a negative. Okay, because we know that positive, in the case of positive overlapping only, the bond will be formed, right? So positive, when they overlap, here the bond formation takes place, and negative negative, when they overlap, bond formation takes place. And you can see this is this which type of interaction it is, two lobe interaction. Two lobes का interaction हो रहा है यहाँ पे, right? And you can see the lobes are above and below the internuclear axis. You can see the lobes are, this is internuclear axis, right? Imaginary axis, right? And the lobes are above and below the internuclear axis. So when you see this type of interaction, and when the lobes are above and below the internuclear axis, so in this case, pi bond will be formed. Pi bond will be formed. And pi bond को हम कैसे show करते हैं? Pi bond. Is it clear?
Yeah,
Yeah,
ma'am.
ma'am.
Yes.
Okay. So these are very, very important, sigma and pi bond, but there is another bond too, four lobe interaction. Okay. So suppose we know that D का shape क्या आता है? Double dumbbell shape, right? So P orbital shape is dumbbell shape and the D orbital shape is double dumbbell shape. So suppose we have a D orbital. Suppose, okay, and another one, right? Here's the imaginary axis, right? This is the imaginary axis. This is your internuclear axis. Okay. So when this type of interaction is four lobe interaction, what happens here? ये दोनों जो हैं, these will make bond with each other, but ये दोनों के बीच में भी, इन दोनों के बीच में भी interaction होगा. Okay, not that strong, weak ही interaction होगा, but उन दोनों lobes के बीच में भी interaction होगा. So that type of interaction is known as four lobe interaction. And write down in four lobe interaction, lobes are again above and below the internuclear axis. Okay, the lobes are above and below the internuclear axis, and in this case, when the four lobe interaction will be there, then in this case, the delta bond will be, delta bond formation होगा, and delta को हम ऐसे show करते हैं, that is your delta bond. Okay. So the most important thing is 1 and 2 point mean the sigma bond and the pi bond के बारे में आपको पढ़ना है. You don't have to no more discussion about the delta bond in details. Okay, we will discuss sigma and pi bond in details because these are given in your syllabus. But just remember, when the four lobe interaction is there, so the lobes are above and below the internuclear axis, and in that type of interaction, delta bond formation होता है. Clear?
Yeah, ma'am.
Yes, ma'am.
And most of the time, internuclear axis most of the time, or usually you can say, usually taken as z axis, the same as a z axis की तरह लेते हैं. Okay, and when the bond is formed, so each orbital should have one electron with opposite spin. The spin should be opposite. Suppose if one atom has a valence electron which has a up spin, so the जिसके साथ वो bond formation कर रहा है, the another atom should have the opposite spin. Then only the bond formation takes. Just remember that. Done?
Yeah, ma'am.
Okay, next write down the formation of sigma bond. Okay, so how sigma bond form? So sigma bond is formed when there is an end to end or head on, or you can say axial overlapping of atomic orbital on internuclear axis, which forms sigma bond. Okay, sigma bond कैसे form करता है? So it formed when the end to end or head on, or basically you can write axial overlapping is there. Suppose कब बनेगा sigma bond? So sigma bond will be formed when there is S overlapping, when the s orbital overlap with the s orbital, another s orbital. Second, it will be formed when S or P, sp overlap, when s and p orbital overlap. And third, it will be formed when pp overlap. In these three cases, the sigma bond is formed. Okay, so we have discussed, I think, both all the, you can see over here, when the ss orbital, this s orbital and s orbital, when they overlap, so it leads to the formation of sigma bond. Second example, this is your pp overlap. Okay, so when the two orbitals, this is your px and px, when they combine, when they overlap, again they will form a sigma bond. Okay, and when the s and p, this type of overlapping, one s and the second one is your p. See this, one s orbital and this is your p orbital. When they overlap, again the sigma bond will be formed. यहाँ पे क्या होगा? Sigma bond formation will be there. Okay, so sigma bond is formed in these three cases: SS overlap, SP overlap, and PP overlap. Okay, you can draw the diagram over here. This is, suppose this is your internuclear axis. This is your s orbital. Okay, another s orbital. Right here, the overlapping. Okay, so this is your sigma bond. Similarly, sp orbital. Suppose this is your s orbital and this is your p orbital. And here the overlap occurs. And this is your sigma bond. This is your pp. Okay, so this is your internuclear axis. This is your p orbital, another p orbital. Okay, here the overlap occurs, and this leads to the formation of sigma. Okay, and if the bond is formed, it means the positive overlapping यहाँ पे हो रहा है, not the negative and the zero overlapping. We are talking about the positive overlapping because bond is formed. Okay, and which type of bond is formed? When the SS overlap, SP overlaps, and PP overlaps, the sigma bond is formed. Clear?
Yeah, ma'am.
Yeah, ma'am.
Okay. Right on the
Can you
second one. Yeah. Yes, Aisha. Okay. Next, write down the formation of pi bond. Formation of pi bond. Okay, so pi bond is formed when there is a lateral or sideways overlapping. Side overlapping होता है when the orbital का, atomic orbital का, then only the pi bond is formed. Lateral or sidewise overlapping of atomic orbital along internuclear axis. Okay, and pi bond are basically of three types. Pi bond is formed in the three cases. First case, when there is a p pi, first type is p pi bond. P pi bond. Okay, suppose so py axis. Py axis, obviously, ये होगा py axis, and the another p pi between these. So here the overlapping occurs, and here, right? So in this type, this is your, so that this is internuclear axis, and this is your p orbital and another p orbital, right? So between these two, you can see this is a p pi p. वहाँ पे pi bond का formation हुआ है, that's why we call it as a, and the orbital is p, right? And the formation of pi bond is there, so that's why we call it as a p pi type of bond or interaction. Second type, p pi d pi, p pi and d pi. Okay, so obviously one orbital is from the p and the other is d orbital. So p orbital, you will show it like this. Okay, so this is a p plus and this is a minus, and d orbital. So how many? What is the shape of the d orbital? Double dumbbell shape, right? So four lobes you have to show. Four lobes. So one lobe overlapping, two lobe, three lobe, four lobe. Okay, so this is a positive, right? Because the bond is bond formation is there, bond is forming. So obviously this one may be positive. Positive interaction will lead to the overlapping and the bond formation, right? So this is the overlapping, and this is the overlapping. Okay, and the bond is formed, which is known as pi bond. And this type of interaction is known as p pi d pi bond. Why? Why this is known as p pi d pi? Because the orbital is from the p orbital. The bond is formed between the p orbital and the d orbital. Okay, and which type of bond is formed? Pi bond. Okay, so that's why p pi d pi type of interaction. Third one, d pi d pi, d pi and d pi type of interaction. Okay, so very easy. So one orbital is from the, both the orbitals are d orbital, right? One, two, three, and your four, right? So overlapping. Suppose this is a minus, so this will be minus. If this is positive, so this will be positive. Okay, this will be plus, this will be minus, plus, and minus. Okay, is it clear?
Yeah, ma'am.
Okay, now write down the note. Yeah. See, in the s orbital, only one lobe is there, right? So s orbital has only one lobe, so it can only form sigma bond. Okay, s orbital हमारा pi bond formation नहीं करता, just remember that. So since, write down first point, since s orbital has only one lobe, it can form only sigma bond. ये pi bond नहीं बना सकता s orbital. Second point, p orbital, p orbital has two lobes, has two lobes. So it can both form, it can form both, can form both sigma and pi bond. Similarly, when we talk about the d orbital, so d orbital has four lobes, right? So it can form sigma, pi, as well as your delta bond. Right, ये तीनों bonds बनाते हैं, delta, sigma and pi. And yeah, one more thing, just remember, the pi bond is formed after the formation of sigma bond. Pi bond कभी भी single आपका formation नहीं होता. First the sigma bond will be formed, after that pi bond is formed. Always, right? ये हमेशा कभी भी अकेले exist नहीं करता है pi bond. It always exists in the with the sigma bond. Okay, after the formation of sigma bond, पहले sigma bond का formation होगा, then only the pi bond will be formed. And the pi bond is basically less stable होते हैं and they are more reactive. Okay, pi bond is more reactive and less stable, just remember that. And they are weak. ये weak होते हैं as compared to the sigma bond, because sigma bond is formed by the proper overlapping के through sigma bond formation होता है. But pi bond पे क्या होता है, they are not as much overlapping वहां पे होती है जितनी होनी चाहिए as compared to the sigma bond. So that's why pi bond is weak as compared to the sigma bond. Right? If you want to differentiate, write down the difference between the sigma and pi bond, so you can write here the difference between the sigma bond and pi bond. Pi bond. Yeah, so it results from end to end, results from end to end overlapping of two s orbitals or two p orbitals or one s and one p orbitals, right? And in this pi bond, it results from sidewise, or lateral, you can say lateral overlap. This one is a strong, but this one is weak. This one is more stable. This one is less stable. This one is less reactive, but this one is more reactive. Yeah, next, more important, it can independently exist. ये independently exist कर सकते हैं. Exist, but this always exist along with a sigma bond, right? So pi bond always exists along with the sigma. Okay, ये single exist नहीं करते. Okay, yeah, that's all. And yeah, sigma bond is sigma electrons, because sigma bond is formed by the electrons, by the two electrons. But the pi bond, so sigma bond, sigma electrons are localized. They are referred to as a localized. They are not mobile, right? Referred to as, they are localized होते हैं. They are not mobile electrons. But the pi electrons,
localized and mobile.
yeah, see, mobile means the electrons can be moved. Electrons move कर सकते हैं. Suppose in the benzene, see, there is a pi electron, right? Alternate, single and double bond. So ये क्या है? Pi electrons. So pi electrons are mobile electrons. They are delocalized, right? ये क्या करते हैं? ये move कर देते हैं. ये move करते हैं and they just form the resonating structure. They form the resonating structure and they are more reactive. they are more reactive. They participate in the bond formation and in any chemical reaction, and they are more reactive. So basically, the localized means the sigma electrons are referred to as a localized means they are immobile. वो move नहीं करते हैं, right? अब किसी भी bond formation हो, किसी भी chemical reaction हो, they don't move. But the pi electrons are movable. Okay, the electrons are held firmly, very firmly. There is a, you can see, weak bond होता है, right? Weak होता है तो their electrons are weakly held. Okay, बहुत ही weak force of attraction होता है between the electrons, and they can easily dissociate. They can easily dissociate, and the electrons can easily move from one carbon to another carbon and so on, which creates a resonating structure. Right. So sigma bond जो होता है आपका immobile होता है and they are localized, but the pi bond is, or pi electrons are your delocalized, you can say, or mobile electrons. Clear now?
Yeah, ma'am. Thank you.
Pi yeah. One more thing, the sigma, due to the shape of molecule is basically is determined by the sigma bond, by sigma bonds present in the molecules. But pi bonding does not affect the shape of molecule. The shape of molecule. Yeah, so that's the difference between the sigma and pi, so pi bond. Now let's do some questions. I'm writing a question here. You have to tell me which type of bond will be formed by the overlapping of the following orbitals. So consider, and you have to consider the x-axis. X-axis as internuclear axis. Okay, आपको x-axis को consider करना है as a internuclear axis. So what type of bond will be formed by the combination of first 1s and 1s. 1s orbital and 1s orbital के overlapping से which type of bond will be formed. Second is 1s and 2s. Third is 2s and 3s. There is 2px and 2px. 3py and 2py. Yeah. Consider this orbital and just tell me which type of bond will be formed. Yes, first, Neha, tell me. 1s and 1s, when they overlap, which type of bond will be formed?
Sigma bond.
Yes, very good. Sigma bond. Yes, Zanab, second, 1s and when 2s, when they overlap, which type of bond will be formed? Yes, Zanab. This is s orbital, see? So when s orbital, they overlap, which type of, yeah. Let's check sigma bond. Aisha, third one. 2s and 3s?
Mom, again sigma.
Yes, sigma. Yes, Humera. D. When 2px and 2px, when they combine, when they overlap, which type of bond will be formed?
Pi bond.
I bond. Are you sure? Is she correct? Yes, Sanidhi, tell me. Yes, Humera.
The D one or E?
D.
Mom, isn't ma'am sigma bond?
Yes, sigma bond will be correct. See, question paro. Consider the x-axis. X-axis, this is the x-axis. Consider it as a internuclear axis, right? Now, question number D is 2px. Means p-axis, p orbital is along the x-axis, right? So this is your 2px, and another is 2px. Another one is also 2px, right? Now, which type of overlapping it is? This type of overlapping. One lobe overlapping, right? One lobe overlapping. So this is your sigma bond, not the pi bond, right? This you can see. This is your S, basically your, yeah. See here. What is the condition for the sigma bond formation? End to end, right? Or head on or axial overlapping, right? So you can see, or simply आप ये भी देख सकते हो, this is a one lobe interaction, right? Only one lobe is interacting with each other, so it's a sigma bond. Okay, when one lobe interact with each other, there is a formation of sigma bond. तो यहाँ पे sigma bond formation. Okay, but in this case, अगर यहाँ पे x axis, consider the z axis और y axis as internuclear axis होता, then यहाँ पे क्या होता, it will form, suppose in question में मैं change कर दूं, suppose y axis, internuclear axis, suppose we have a y axis as a internuclear axis, this one, right? This one is a internuclear axis, y axis को हमने बोल दिया, and the orbital is px and py. So px तो obviously इसी के basis पे होगा. This is the px, one px, and this is another px. Now you can see there is two lobe interaction. Two lobe interaction, right? So two lobe interaction it is, and this type of overlapping is known as pi bond. Okay, but here the question में क्या है? As the x-axis, it is mentioned over here. The internuclear axis is x-axis. So in this case, there is a pi bond. Sorry, sigma bond. It is sigma bond. Okay. Yes, Sanidhi, last one. When 3py and 2py, when they overlap, which type of bond will be formed?
Mom, pi bond.
Yeah, in this case, pi bond will be formed. Very good. Clear, all of you?
Yeah, mom.
Yes, ma'am. Yeah, ma'am.
Mom, can you explain the last one?
Yeah, sure. See, this is your, we have to consider this. This x-axis, suppose this is your x-axis, this is your internuclear axis. Because as in the question it is given, consider the x-axis as internuclear axis. Now this is py. This is, suppose this is your x-axis, so y किस direction में होगा? Obviously lateral direction. So py, this is your py orbital. Okay, so this is 3 pi py orbital and this 2 pi py orbital, just like this. तो यहाँ पे क्या हो रहा है? There is a two lobe interaction, right? So this
Okay, mom,
will
got it.
form the pi bond. Okay. Oh,
Yeah, mom, thank you.
okay, write down the remarks. According to valence bond theory, as I told you, pi bond is formed only after the formation of sigma bond. Sigma bond. First sigma bond will be formed. After that, pi bond will be formed. Second point, sigma bond is stronger than pi bond. Pi bond. Why? Due to head-on overlapping. Due to head-on overlapping. Head-on overlapping की वजह से क्या होता है? The area of overlapping is more than that in the case of pi bonding. Pi bonding में sideways overlapping होती है. Sideways की वजह से क्या होता है? Overlapping जो area होता है that is minimum. Minimum area वहां पे overlap करते हैं. Due to that, the sigma bond is more stronger than the pi bond. Okay, due to head-on overlapping in sigma bond. Okay, now let's do some question. First, see, question is identify the number of sigma and pi bonds. Pi bonds in the following. In the following. First one in methane. Second one in CH2, CH2, ethene. Third one CH3, CH. Okay. First see, first try to draw the structure. This is carbon, 4 hydrogen is there. Okay. So how many pi bond, sigma bond is there? So आपको अगर single bond दिख रहा है, suppose this is a single carbon and hydrogen के बीच में only one bond, right? Single bond, so this is your sigma bond. One sigma bond, second sigma bond, third sigma bond, and fourth sigma bond. There is no pi bond, right? So sigma bond is 4, right? Pi bond is 0. Similarly, in the second one, when you open this structure carbon, and there are 2 hydrogen. This is your ethene. Okay, so now see this carbon, between these carbon, there is a double bond. So always, जब वहाँ पे double bond होगा, तो one will be first, the sigma bond is formed. When there is a double bond or triple bond, तो first क्या होगा उसमें sigma bond होगा and the second bond is your pi, right? First bond, because both दोनों ही आपका sigma pi bond नहीं होगा. As I told you, the sigma bond is formed only after the formation of the pi bond is formed only after the formation of sigma bond. So first between these carbon there is a double bond. So first the sigma bond is formed. After that the pi bond will be. And this is your sigma. So how many sigma bond? 1, 2, 3, 4, 5. 5 sigma bond and how many pi bonds? Only one pi bond. Is it clear?
Yes, ma'am.
Yes, ma'am.
See the third one. If suppose कहीं पे भी आपको triple bond दिख जाए, triple bond कहीं पे भी दिखे, so just remember first one जो होगा आपका sigma होगा and the other 2 are pi bond. In the triple bond की बात हो रही है. If there is a carbon one single bond, so इसमें 0 sigma bond, 0 pi bond है. Okay, and sigma bond is 1 sigma. If there is a carbon double bond, so 1 sigma, 1 pi and 1 sigma. If there is a triple bond, so 1 sigma and 2 pi. Just remember that. So first sigma bond is formed. After that 2 pi bond will be formed. Okay. So let's calculate how many sigma and how many pi bonds are there. So when you open this equation and how many, okay, so 3 hydrogens. Okay, so see, so this is your 1 sigma bond and these 2 are pi bond. This is your sigma bond, single bond, right? Sigma. So how many sigma bond? 1, 2, 3, 4, 5. So 5 here. Okay, just a second. It was CH3, Just a second. The structure is wrong, I think. I just missed this carbon. One carbon is missing over here. See, the structure you have to draw this. CH3, right? So this carbon, this triple bond, this hydrogen, right? Now, this again, there is a carbon, right? 1, 2, 3 carbon, right? मैंने एक carbon मैं भूल गई थी, right? So 1, 3. Now it's a correct structure. Now just try to find the sigma and pi bond. 1 sigma bond, 2 sigma bond, 3 sigma bond. Again, see, there's a carbon-carbon के बीच में single bond, so you will get 1 sigma bond. And this is a triple bond. So 1 sigma and 2 pi. And again the sigma bond. So how many sigma bond and how many pi bonds are there? So 4 plus 2, 6 sigma bond and 2 pi bond. Clear?
Yes, ma'am.
Okay, so that's how we just identify the number of sigma and pi bond in any molecule or any compound. That's very easy. Okay, right now. Written?
Yes, ma'am.
Okay. So you guys have another class now? Yes. आप लोगों की another class है क्या अभी? Hello. Okay, so the next topic we will discuss in the next class, inshallah, because I think here a few students have left the class. So we will discuss the formation of hydrogen, H2, right? And the formation of different molecules by this method. And we will discuss that how many electrons and how many sigma bond and pi bond will be there. Okay, so just be prepared. And hello,
Yes, ma'am.
am I audible?
Yes, ma'am, you are audible.
Okay, okay. Okay, so please revise all the topics, and if you have any doubt, you can ask in the next.
Okay, ma'am. Thank you.
Okay.